This is frequency domain, so the F should be here instead of there.
Yeah. Sorry. Frequency band, but here this is frequency. Yeah, right. So he said frequency here. That's correct. But I mentioned for the white noise, where we have a white noise. Well, think about this. We have a white noise. Where we have a white noise? Initially we have a frequency band here through the codes, and then we have a frequency band like this. Actually, you can use some signal processing to understand if we have a frequency actually spectrum like this, then we will have an area. And area actually talking about power or energy. So in fact, we will have the same area. That says to spread and to maintain the same area, something like we have the same energy. Then we need to have a flat spectrum. Flat spectrum, so of course we need to have a low level, and low level actually similar to the previous white noise. And white noise maybe even lower, or maybe comparably low. Well, here I just want to talk about if we have this one, and then code to spray and code again. Code and code and code again. So we have spread spectrum, and so that we have a narrow band again. Well, right now we have an operation like this, and we can use code to spread. All right, and normally we will have noise, right? And using the previous one, actually, for example, I use this way. If we have a noise, maybe I use a different color. I just want to mention, if we have the background noise, and then background noise multiply code, so something like we have this. And again, however, we will have a spready one. So about noise, actually, it won't affect a lot. So that's why we still can recover the signal. And also, we have another one, jamming. Jamming says we intentionally transmit one signal with intensity signal, so it's jamming. 这 jamming 其实就像是轰炸。Jamming signal, so here, something like we have a jamming. Sorry, then we have a jamming. Jamming something like this. And here, this is original signal. And jamming signal like this. So, is it okay to jam the transmit signal in a spectrum system? Sure, you can do so. But jamming something like this is previous. I mean, this is the noise, so that we can see the peak. And if you want to have a peak, this peak we can call jamming, so that we have a jamming signal. And jamming signal same jamming signal here. Therefore, we will have a signal itself, but jamming will be spreading. Again, jamming signal cannot interfere the signal transmitted. All right, so because of the feature, therefore we like sparse throttle. And someone likes sparse throttle so that we have a CDMA and so that we have the other possible further development. All right, about this, maybe you can try to check the other books to understand the others. I just let you know, yes, we have a good feature. So that's why we expect sparse throttle, and we expect CDMA, and we expect frequency hopping. All right, that's all. So maybe later in the other chapter, perhaps we can have the concept to let you know a bit more. Well, that's it. So OFDM and CDMA and frequency hopping. And later we want to have the architecture. Here we have the infrastructure. And infrastructure, of course, for the cellular system, we will have the area, the cell site cover. Here, the cell site we call base station. And the service area, of course, we call the coverage. All right, we will have the coverage by the base station, and the base station just use its carrier to cover this one. And of course, we will have a different carrier, carrier 1, carrier 2, and the others who have the different service area. Therefore, we won't have the same frequency to interfere each service area. Well, this is the fundamental one, infrastructure of the cellular system. And this we need to have the base station, actually the cell site of the service area. Cell site. Well, one cell site, and we still have the other cell site. So we'll have cell site 1, sorry, here 1, 2, 3, 4, 5, 6, 7. If we can have the cell, for example, using the current structure 1 to 7, and 1 to 7 can form a specific area, and the specific area can share all the resources, radio resources. For example, we have, 49 channels, and you can share by the 7 cells here. So we will have 7, 7, and 7, and 7. We have 7 channels in different cell. Well, in a different cell, so this one won't interfere with this, won't interfere with this, won't interfere with the surrounding cells. No interference, right? However, on this, of course, no. We want to, someone like to have the replica to copy these to the others, and so that we can reuse the frequency band in the other cells. And this one we call the cell, this one we call its frequency reuse. And in chapter 5, we will talk about frequency reuse and how to have the different patterns so that we can copy to the others. And so that for the corresponding position, for example here, you can find the corresponding position. And the 7 channels can be reused by the others, Think about this. First of all, within the area here, we don't reuse the frequency, but we can have the replication, and so that we will find the corresponding cell, maybe using the seven channels here. So of course we can reuse. Therefore, this is a pattern. The pattern so that we can achieve frequency reuse. All right, in chapter 5, we will talk about this concept about frequency reuse.